This is the June 2013 regional exam for C1. This is the question 8. So it's going to be everything that we've learned about linear and quadratic inequalities together in a question, but also with worded questions, so it's slightly more difficult. Let me read it to you now. A rectangular room has a width of x meters. The length of the room is 4 meters longer than its width. Given that the perimeter of the room is greater than 19.2, show that x is greater than 2.8. So let's draw this rectangle to start. So if we put the x here on the smaller side, so that would be the width, the length of the room is 4 meters longer. So that will be x plus 4. Now remember, if we're dealing with a rectangle, then opposite sides have the same length. So these are both x and these are both x plus 4. Given that the perimeter of the room is greater than 19.2, well, let's start by working out what is the perimeter of the room. The perimeter of the room is all of the sides added together. So if I take a different color and I add up this side, well, that's x plus 4. And then I add up this side, well, that's x. And here I have another x. And I have another x plus 4. So I have x plus 4, x plus 4, x and x. So if I add together all my like terms, so let's see, how many x's do I have? I have 1, 2, 3, 4 x's, and I have 4 and 4 for 8. So this is my perimeter. My perimeter is 4x plus 8. I've been told that the perimeter is greater than 19.2. So this is my greater than symbol, 19.2. Now, we can take off the p. This turns into a linear inequality, just like the ones we did in the earlier key skills 1 and key skills 2. That means what we want to do is we want to put all of the numbers together on one side, and we want to keep the x's on another side. So we want this number here to go on the same side as the 19.2. But don't forget, as it moves over, it will change from a plus to a minus. So let's move it over to be on the same side as 19.2. So now I need to do 19.2 minus 8. So I'm going to have, move this in a little bit, I'm going to have 4x is greater than 11.2. To find that x is greater than, I need to divide both sides by 4. So if I imagine I've divided this side by 4 and this side by 4. So 11.2 divided by 4, 2.8. So as you can see at the end, I have, as the question required me to, x is greater than 2.8. If you want to draw a quick diagram on the next page so that we remember what that looks like. So if I have here 2.8, well, this is my y. So last time it's 2.8. So if this is 3, I want to draw my line just in front of my 3. And because it's x is greater than, remember, less than to the left, greater than is going to go to the right. So I'm going to shade everything going this direction after x is equal to 2.8. I'm going to put it in as a dotted line to remind myself it's greater than 2.8. It's not greater than or equal to, which I would have a solid line for. So that wraps up part A. And now we're going to look at part B in the next video. Hey, so this is part B of June 2013, question 8 from C1. So don't forget, we're talking about this rectangle that we said looks like this. It's got one side 4 meters longer than the other side. I'm going to rub out these two because we don't need these anymore. So let's read the part B. Given that also the area of the room is less than 21 meters, write down an inequality in terms of x and solve the inequality. So let's copy our rectangle onto the next page. So this is our rectangle. So what would the area be of this shape? Well, to calculate area, we generally do, we multiply the sides together for a rectangle. So we would do x multiplied by x plus 4, or length times width. So x times x is x squared plus x times 4 is 4x. So the area of this shape is x squared plus 4x. Okay, now we want here the fact that the area is less than 21. So I take my equation for the area and make that less than 21. What I'm going to do here, because it's a quadratic, I want everything on the same side. So I need to move the 21 over to the left hand side. So I'm going to have x squared plus 4x minus 21 less than 0. And that's the first part. The first part asks you to form an inequality. So let's put a little box around that. Now we have to solve that inequality. And if you remember, if we have a quadratic inequality like this one, the first step was to factorize it. If you're struggling with a quadratic inequality, skip back a couple of videos and look at the 3 videos that I've already covered how to solve quadratic inequalities. So here I'm looking for 2 numbers that multiply together to give me minus 21 and add up to give me 4. So those numbers are going to be 7 and minus 3. Now the reason there's 7 and minus 3 is 7 times minus 3 gives me minus 21. I've got a plus sign and a minus sign. And 7 take away 3 will give me 4. Again, if you need more information about that, skip back a couple of videos. I'm going to find the 2 solutions from this bracket by making each one equal to 0. So x plus 7 equals to 0 gives me my first solution, which is x equals to minus 7. Remember that plus 7 will go over here and become minus 7. That can be the pink solution. And the other solution, I'm going to go over here, which was x minus 3 equals to 0. Or x equals to 3, and that can be the green solution. We use these 2 solutions of the graph x squared plus 4x minus 21, that would be equal to 0, to draw a rough sketch. So draw your coordinate axis system and make sure you have space going up to minus 7 and 3. So 1, 2, 3, 4, 5, 6, 7, right on the end. X equals to minus 7. And over here we have x equals to 3. 1, 2, 3, and that's our green solution. We also need to have, don't forget, your x and y. Don't worry about making this too neat, it's just more so that you can identify where the correct regions are. So because it's a plus x squared graph, I'm going to draw my happy face. Remember, positive, happy one. So my graph will look like this. Not too beautiful, but it will do. Now I'm going to take a different color and I'm going to shade. Because it's less than 0, remember, I need to shade underneath the graph. So I've shaded in one place, which means I'll have one solution. And my solution will go from x is equal to minus 7 up to x is equal to 3. So the final answer for part B is minus 7 less than x less than 3, or x is in between these 2 values. Quick recap, we formed an equation multiplying the length together with the width to get the area. That was less than 21 from the question. We moved that over. That gave us a quadratic. We factorized our quadratic and got the 2 points, which let us draw a rough sketch. Because it was less than 0, we shaded underneath. There was one place shaded, so one answer, and that was between -7 and +3. Stick around, there's one last part in this question. The final part says, hence find the range of possible values for x. So if you remember, for the first answer we had x is greater than 2.8, that was to do with the perimeter. And the second answer down here, we had x is between -7 and 3. So to find the region where both of these values are true, both of them are true, what we're going to do is we're going to draw both graphs together on top of each other. So take your first graph. Okay, so that was we've got between -7 and 3 shaded underneath the graph. And you take your answer from the first section, which is x is bigger than 2.8. So let's draw that in. So 2.8, here's 3. So 2.8, don't forget, is just in front. That's here, that's 2.8. And this time we shaded, it was greater than, so we shaded to the right. So we look at where the two graphs cross over, and there's only a very small space. You can hardly see it where they cross over. And that's between 2.8, where you still have a yellow graph, and 3. So you have both colors there. If you can see underneath, you've got the yellow here, but also the green on top. So where both of them are true is between, x is in between 2.8 and 3. That's both answers. Okay, so that's the end of the question. That's as difficult as it gets. And I hope you understood. And give me a thumbs up and a like, please. Bye for now.